Hello everyone, welcome back to Mathself. In today's video, we will be going through circle theorem. So circle theorems are a set of theorems that's already proven. That means you can simply use them in your working out or questions in exam. So there are 8 main theorems that you need to know of, which is shown on the board. And we'll be going through what they mean one at a time. Yeah. So theorem number 1 is the angle at the center is twice the angle at the circumference. What does this mean? This means that the angle that is at the center of the triangle of the circle, so this is the center of the circle, is twice the angle at the circumference. So you must always look for a shape like this. So it's always best to remember the circle theorem's rules visually. For example, you can kind of see that it looks like an arrowhead, so you can remember it as the arrowhead rule. Yeah. But keep in mind that the shape looks different depending on what kind of angle this is. If you have an angle at the center that is bigger than 180, the diagram would look slightly different. It would look more like this, which means this is angle 2A and this would be angle A. So depending on how big or small the angle in the center is, the shape looks slightly different, but most of the time the shape looks like an arrowhead. But that's pretty much it. Angle at the center is twice the angle at the circumference. That is for rule number 1 or theorem number 1. Then we have theorem number 2, which is angles in the same segment are equal. So I used to call this the bow tie rule, just because it looks like a bow tie. So it's always important to visually learn this rule because you have to spot this in exam. Yeah. Always remember this short line that you can write. So what does this rule say? So this rule tells you that these two angles are the same. But you need to keep in mind that all the 4 corners of this shape needs to be in the circumference. So if you have a shape like this, where the 4th one doesn't touch the circumference, you cannot use this rule. So always keep in mind all 4 points needs to be in the circumference of the circle, and you have these 2 angles which are the same. So when they say the same segment, they mean like this. You have 2 triangles going from the same segment. So from the same segment, so they are equal. By the same logic, you can say that these 2 angles are equal as well. So as long as the shape is from one same segment, you can say the angles are equal. So this rule is angles in the same segment are equal. Now rule number 3 is the angle in a semicircle is 90 degrees. So what they mean by this is if you have set the diameter of the circle as one of the sides, then the angle that touches the circumference would always be a 90 degree. What they mean by that is if I have an triangle like this, this would be 90 degree. If I have one like this would be 90 degree. If I have one like this would also be 90 degree. So as long as I have a side for a triangle that is the diameter of the circle, the angle here would always be 90 degree. And you can explain that rule as the angle in the semicircle is 90 degrees. It's pretty straightforward. You can easily spot it if you can see that one of the sides is the diameter. Yeah, that's it for this rule. And for the 4th rule, opposite angles in a cyclic quadrilateral add up to 180 degrees. So in this rule, there are certain things, keywords, the opposite angles, cyclic quadrilateral, add up to 180 degrees. So what is a cyclic quadrilateral? A cyclic quadrilateral is just a four-sided shape inside a circle. And the rule is that all four corners of that quadrilateral must touch the circumference of the circle. So if you have something like this is not a cyclic quadrilateral because this does not touch the circle. So always keep in mind that the quadrilateral needs to touch the circumference. All four corners needs to touch the circumference of the circle. And the rule states that the opposite angles add together. So in this case, C plus D is 180, A plus B is 180. Quite straightforward rule and can be easily spotted in a diagram in question. So that was rule number 4, and we have rule number 5 here. The perpendicular from the center to the chord bisects the chord. When they say the perpendicular from the center, they're referring to the radius. So if what that means is if you have any radius that crosses a chord in a circle, it perpendicularly bisects it. So for example, if I have a chord here and the radius goes through it, then it splits perfectly in half with 90 degrees. So it's a perpendicular bisection. So in this case, this would be the radius and you have a chord, it perfectly bisects it and you can see that's 90 degrees. So I would suggest remember this exact line, the perpendicular from the center to the chord bisects the chord. So the perpendicular from the center to the chord bisects the chord. So this one is harder to understand because people tend not to get what perpendicular from center can always mean radius. So perpendicular from center is basically radius. So keep that in mind. Yeah. Now for rule number 6, the angle between a tangent and a radius is 90 degrees. Pretty straightforward. So you have a radius of the circle, and if a tangent meets it, tangent and the radius meets, you have a 90 degree. So tangent is a line that just touches the circle. It never crosses. It only touches the circle at one point. So when the radius meets at that point, that becomes a 90 degree. Pretty straightforward. And rule number 7 is tangents from a point outside the circle are equal in length. So if you have two tangents to the circle that originates from a point that makes the circle, then these two lengths are the same. So these two are tangents of the circle and they both originate from the same point. Hence the distance is same. So they have the same length. For example, if this is 8 centimeters, this is also 8 centimeters. And finally, the 8th and final rule, alternate segment theorem. It's quite easy to remember, but most people don't tend to use this because it's quite hard to visually spot them. The rule itself, alternate segment theorem, easy to remember but harder to spot. So for this rule, you require a tangent and a triangle with all three corners being in the circumference. Once again, you cannot have it as something like this. It needs to be, all three corners needs to be in the circumference. So according to this rule, if this is angle A, this can be angle A. And if this is angle B, this will be angle B. So in an exam, if they give you this angle and you need to find out what this angle is, you can say this angle is B because of alternate segment theorem. So simply you need to spot this in the sense that they are alternate to each other. So if, just as a tip, what I would suggest is always think of them being in an L shape. So they need to fall within this L shape. and when they fall within this L shape, they are same. So feel free to always come up with your own rules, right? How can you remember that these two angles are the same? The rule I came up with for myself is that it has an L shape, so the ones that fall in that L shape are the same. This L shape that's faced the opposite direction or falls in them are the same. That just works for me, but it might not work for you. So come up with a way which is easier for you to remember. So that's pretty much it for circle theorems. These are the 8 main rules. Let me know if you need the diagram. I can happily put this in the description. And if you have any questions, just ask me in the comment section. So this video would just be about learning these 8 rules, and I will be surely releasing another video which goes through practice questions. I didn't want this to be a big video, so just made this to be an information one, the next one to be a practical one. Let me know if you have any questions, and hope you have a nice day.